Students, do the homework on video page 401, numbers 11 through 16. On these problems, just 6 of them, we are going to simply take an ordered pair and see if it is a solution to the given linear system. Okay, so here we go. Number 11, we're going to test 5, 2. 5 is your x value, 2 is your y value. We take our first equation, where the x is, I substitute a 5. Where the y is, I substitute a 2. And let's see if I get out a true or false statement. 15, negative 2, positive 2, negative 4. And we get 11 equals 11. So far, so good. But remember, students, this ordered pair must satisfy both equations, not just one, okay? So let's also substitute this ordered pair into the bottom equation here. So where the x is, I will substitute a 5. Where the y is, I will substitute a 2. Alright? Negative 5, positive 12, and we get 7 equals 7, so that's checks. So, is this ordered pair a solution for this linear system? The answer is yes, it is. Why? Because it satisfied both equations. Number 12, here we go. Let's take your first equation, write it down. This is your x value, this is your y value. So 6 parentheses negative 2, negative 3 parentheses 1. 6 times negative 2, negative 12. 3 times negative 1, negative 3. And we get negative 15 equals negative 15. Alright, now let's take our second equation. When the x is, I will substitute a negative 2. When the y is, I will substitute a 1. And we get negative 4, positive 1, which equals negative 3. So it checks. So we're good. Number 13. Alright, let's take our top equation here. Yes, sir. So students, where the x is, I will substitute a 3. And where the y is, I will substitute negative 6. Alright, here we go. Positive 3. Negative 18 equals 15. So I get negative 15 equals 15. That is not a true statement. Negative 15 does not equal 15. So we can stop right now. There is no need to test this ordered pair in the second equation. If it fails in one, we know right away it is not a solution. So 3, negative 6 is not the solution to this linear system. Alright, moving on to number 14. Okay, students, let's take a look now at number 14. Let's copy our first equation. Now let's substitute our values in for the variables. So negative 5 parentheses negative 4 plus y negative 1. And we get positive 20, negative 1, which does give you 19. So far, so good. Now let's check this ordered pair in our second equation. And where the x is, I will substitute negative 4. Where the y is, I will substitute negative 1. Negative 4, positive 7, which does give you 3 equals 3. So we're good. So yes, this ordered pair is a solution to this system here. Number 15. Let's copy now our first equation. When the x is, I will substitute 3. When the y is, I will substitute 5. And I will get negative 45, positive 35. And obviously, that's not going to give me out a true statement. So, no, this ordered pair is not a solution for number 15. If it fails in the first one, then there's no need to substitute it into the second equation. Okay? Number 16. Let's copy now on our first equation here. When the x is, I will substitute a 6. When the y is, I will substitute a 1. And we get negative 12, positive 1, which does give me negative 11 equals negative 11. So far, so good. Now let's substitute this point into our second equation. When the x is, I will substitute a 6. When the y is, I will substitute a 1. Negative 6, negative 9, and of course that does equal negative 15. So there we go. So this ordered pair does satisfy both equations. So yes, this ordered pair is a solution to this system. Okay? Not very difficult, but very important to understanding linear systems. I hope this video has been a help to you. If you have any questions at all, please don't hesitate to contact me.